Solve the equation 2 cos 2x equals 7 cos x, given your solutions to one decimal place. So for this question, we need to use double angle formulae as there is a 2x and that is just on here as well. So we need to use the one just using cos x because we're only dealing with cos x in this question. And this is cos 2x equals 2 cos squared x minus 1. And all we need to do is sub this into this part of the equation. So it will be 2 bracket 2 cos squared x minus 1 equals 7 cos x. And then we need to expand these. So it will be 4 cos squared x minus 2 equals 7 cos x. And now we need to bring it all to one side and make the equation 0. So we'll do that. And it looks like a polynomial equation. So to solve this, just to make it easier, we can set cos to u and rewrite it as 4u squared minus 7u minus 2 equals 0. And using your calculator or by factorizing, you will get u equals minus 1 over 4 and u equals 2. But cos x won't go up till 2, so we only need to look at this minus 1 over 4 value. And we can just change this u back into the cos x. So cos x equals minus 1 over 4. Okay, now all we need to do is find x, and you do this by doing the inverse of cos, which is cos inverse minus 1 over 4, which gives you 104.5 degrees. And to find the second value of cos, we just need to minus 360, which will give us 255.5. Now obviously we can add 360 each time, but that will not be in our interval, so these are the two decimals that you are left with. Express sine x plus 2 cos x in the form r sine x plus a, where r and a are constants. R is greater than 0 and 0 is less than a, which is less than pi over 2. Give the exact value of r and find the value of a in radians to 3 decimal places. Okay, so first we need to get out the formula for r sine x plus a, which is r bracket sine x cos a plus cos x sine a. And we can also factorize this, so we'll put r cos a sine x plus r sine a cos x. And this is going to help us because we now need to compare coefficients. So, oh yeah, we also just equated this to this equation, just this. So compare coefficients. So as you can see from this equation, the coefficient of sine x is 1 and the coefficient of cos x is 2. So r cos a equals 1 because sine x is equal to 1. So this r cos a part is equal to 1. And because cos x is multiplied by 2, this r sine a bit is equal to 2, so it matches. Doing this, we now need to square these equations because by squaring it, we can find our exact value of r. So if we do that, we can sort of put it like this. So we do r cos a squared plus r sine a squared equals 2 squared from here plus 1 squared from here. And if we do that, we can also take the r squared out and then write it like this, which is actually really easy because sine squared a plus cos squared a is equal to 1 if we use our trigonometric identities. So we can rewrite this as r squared 1 equals 5 and r squared will equal 5. So all we need to do is r equals the square root of 5 and that is your exact value of r. Now to get a, we need to use these two coefficient equations that we saw here and divide them, and we'll do r sine a over r cos a. Which gives us tan a equals 2. And now all we need to do is do the inverse of this. So tan inverse 2 equals 1.107 radians, and that is your value for a. Solve for 0 less than equal to x less than pi over 2 the equation 4 sine x is equal to sec x. So to do this, we need to find out the value of sec x, and this is 1 over cos x. And then we can just rewrite this equation. So we can do 4 sine x equals 1 over cos x. And to get rid of this denominator, we can just multiply cos x by 4 sine x, which gives us 4 sine x cos x equals 1. Now, using the formula 2 sine x cos x equals sine 2x, we can rewrite this as 2 sine 2x equals 1 here. And then to find sine 2x on its own, we divide 1 by 2. And then we do the inverse of this, 1 over 2, which gives pi over 6. So 2x equals pi over 6, because when you do this, it equals this value. And then to get the second value in this interval, you do pi minus pi over x, which gives 5 pi over x. And then to find your value of x on its own, you just divide it by 2. So you do pi over 6 divided by 2, and 5 pi over 6 divided by 2, which gives you pi over 12 and 5 pi over 12. Use the substitution t equals tan x to show that the equation 12 tan 2x plus 5 cot x sec squared x equals 0 can be written in the form 5t to the power of 4 minus 24t squared minus 5 equals 0. Okay, so the first thing we need to do is we need to break down each part of the question so that we can convert this part, tan 2x, into tan x, and cot x sec squared x into tan x, so that we can substitute t. So we're going to start off with 12 tan 2x, and we can write tan 2x as 2 tan x over 1 minus tan squared x. We can write cot x as 1 over tan x, and we can write sec squared x is 1 plus tan squared x. Okay, so now we're going to take this tan 2x value and multiply it by 12, which gives us this. And then we're going to substitute tan x for t to make things easier. So it's 12 times 2t over 1 minus t squared. And we'll do the same thing for 5 cot x, which is 5 times 1 over t, or tan x, times the value of sec squared x, which is 1 plus tan squared x, so 1 plus t squared. And we'll just work these out. So this is 24t over 1 minus t squared. And this is 5 plus 5t squared over t. Now, in the question, it says that we should add these two, but because the denominators are different, we need to cross multiply to make sure that the denominators are the same, so that we can go forward and add them. So we do 5 plus 5t squared over t times by 1 minus t squared times by 1 minus t squared on the denominator and the numerator. This will give us 5 minus 5t to the power of 4 over t minus t cubed. And so far as well, we can already see that we've already got our 5t to the power of 4 and our 5. And then we're going to do the same for 24t. So 24t over 1 minus t squared multiplied by t on both sides gives us 24t squared over t minus t cubed. Now all we need to do is add them. So this will give you 24t squared plus 5 minus 5t to the power of 4, which can be written like this. And we can forget about this part of the denominator, as it doesn't really matter. All that needs to equal 0 is this part. So we can rewrite this by multiplying everything by minus 1. And that will give us 5t to the power of 4 minus 24t squared minus 5 equals 0, which is here. Given that 2 sine x minus 60 equals cos x minus 30, show that tan x equals 3 root 3. So for this question, we need to use our addition formulae to work these out. So for sine x minus a equals sine x cos a minus cos x sine a. So using this, we will do x minus 60, so a equals 60. So we put 60 into the a. So sine x minus 60 equals sine x cos 60 minus cos x sine 60. Now for cos x minus 30, is cos x minus a equals cos x cos a plus sine x sine a. And in our case, a is 30, so substitute 30, we get cos x cos 30 plus sine x sine 30. Now the next step that we need to do is we need to rewrite this. So using this sine x minus 60, from here we multiply it by 2 in the brackets, and we leave cos x minus 30 as this, since it's not multiplied by anything. And that is our equation. And then we find out the exact values of each of these for cos x, cos 60, which equals half, sine 60, which equals root 3 over 2, cos 30, which equals root 3 over 2, and sine 30, which equals half. And we plug these back into this equation, which gives us 2 half from here, sine x, minus root 3 over 2 from here, cos x, equals root 3 over 2 cos x plus half sine x. And then we can just expand this, which gives us sine x minus root 3 cos x, as it gets rid of the half and gets rid of the 2, equals root 3 over 2 cos x plus half sine x. And then from here, we just move these around, so we get the sine x on one side and the cos x on one side. So we'll minus this half sine x, so it comes under here. So sine x minus half sine x minus root 3 cos x. And then this will just equal half sine x, as it's 1 minus half. And we get half sine x. And then we need to add this root 3 cos x onto this side. That will give us half sine x equals 3 root 3 over 2. So all of this over 2 cos x. And then we can just multiply both sides by 2 so that we can get rid of these fractions. And that sine x equals 3 root 3 cos x. And by now you should see that we are getting closer to the 3 root 3. And then, as we know, sine x over cos x equals tan x. And that equals 3 root 3. So, following on from the last question, hence or otherwise, solve 0 less than equal to theta less than 180, 2 sine 2 theta equals cos 2 theta plus 30, giving your answers to one decimal place. So we can use the first part of the last question, which is the equation. So we have 2 sine x minus 60 equals cos x minus 30, and as we can see from this equation, the 2 theta actually equates to this part, in the same way this 2 theta plus 30 equates to this part. So we should make these equal. So to make these equal, we would do x minus 60 equals 2 theta, and then to get x on its own, we do plus 60 on both sides. X equals 2 theta plus 60. Now we know that tan x equals 3 root 3 from this equation, and we will need to do the inverse of this to find out what our answers are. However, as x is equal to 2 theta plus 60, we have to sub in this x into here. So we get tan 2 theta plus 60 equals 3 root 3. So yeah. But what we need to do is we need to change this interval, as it is not for tan theta on its own anymore, it's for tan 2 theta plus 60 equals 3 root 3. So we need to get this part of our interval, and then we need to multiply it by 2. So 0 to 2 theta to 360, and then we add 60 on each side. So 0, 2 theta plus 60, and 420, and that is our interval. And now we can work out the inverse of tan 3 root 3, which is 79.1. So 2 theta plus 60 degrees equals 79.1 degrees. To find the next value, we just add 180 for the tan value. So 79.1 plus 180 gives 259.1. And 259.1 plus 180 gives 429. However, this interval states that it has to be less than 420, so that is not a valid solution. So we are just left with these two. Now to get theta on its own, we need to minus 60. So 2 theta equals 19.1 and 199.1. And to get theta on its own, we divide them by 2. So theta equals 9.6 and 99.6.